Hello students, welcome. Today we will discuss the dimensions of physical quantities. So first of all, the dimensions. So the dimensions of physical quantity are the powers to which the base quantity are raised to represent that quantities. So we have studied about the physical quantities. The quantities which can be measured directly or indirectly are called as the physical quantities. Similarly, base quantities. Base quantity are also known as the fundamental quantities, and they are seven in number, seven base quantities or fundamental quantities. For example, length, mass, time. So dimensions of length, how will we write the dimensions of length, dimensions of mass, dimensions of time? So dimensions of length written as L bracket square bracket. Similarly, the dimensions of mass M bracket time T. Dimensions of current A bracket, dimensions of temperature K, that's for Kelvin, luminous intensity CD, candela, amount of substance mole, MOL square bracket. So these are our dimensions of base quantities. Now suppose you are discussing about the dimensions of area. So area, what is area? Area, length into breadth. So length has the dimensions of L, breadth, that is also a length. So L into L, what? L square. So here you can see the power of base quantity, that is L, is raised to power 2. So how we define it? The dimensions of physical quantity are the powers to which the base quantities are raised. So here base quantity, that is length, is raised to power 2, and mass is 0 in dimensionally. L has the power 2 and time also power 2. Now what is dimensional formula? Dimensional formula. Dimensional formula, we just write the dimensions of area, and what we are seeing here, the dimensions of mass, that is power 0, length has power 2, and time has dimensions of 0. So this expression which shows how and which the base quantity represent the dimensions of physical quantity is called the dimension formula. So how we define it? The expression which shows how and which the base quantities, or you can say the fundamental quantities, represent the dimensions of physical quantity. Is called dimensional formula. Let us take example. For example, the volume, it has the formula of length, breadth into height. So length has the dimensions of L, breadth is also a length, so it will be also represented by L, height also L. So what is there? L power 3. So what will be its dimension formula? M power 0, L power 3 and T power 0. So these are the base quantities, that is mass has the power 0, length has the power 3 and time has the power 0. So this formula which is representing how and which the base quantities. So only length in case of volume is representing the dimensions of volume. So this formula is called as the dimensional formula. Now we have another topic, that is dimensional equation. Equation. So equation क्या है? What is this? An equation obtained by equating a physical quantity with its dimension formula. So an equation obtained by equating a physical quantity with its dimensional formula. So how? What is this? Let a physical quantity, we are having area. So what area has the dimension formula? We just derived m power 0, l power 2 and t power 0. So an equation obtained by equating a physical quantity. Now here physical quantity is what? Area. So we will represent it by a square bracket and m power 0, l power 2, t power 0 bracket. It is a dimension formula. So what you are doing, you are equating a physical quantity with its dimension formula. So this equation is called as dimensional equation. Once again you can see a physical quantity when equated with its dimension formula. The equation is termed as the dimensional equation. Now we will discuss some more dimensional formulas. Let density. Dimension formula of density. You can write dimensional formula of some physical quantities So density is what? Density has a formula, mass upon volume. So mass has a dimension of m and volume has a dimension of m power 0, l power 3, t power 0. So right here m power 0, l power 3, t power 0. So now what will happen? M power 1 and here power 0, so it will come as m power 1. Here L power 3, it goes up, so it become minus 3 and t power 0. So this is the dimension formula for density. Similarly, you can find the dimension formula for other quantities. Let speed. So speed, it has the formula distance upon time. So distance has the dimensions of length. So L and time has the dimensions of t. So how will we write it? L power 1, t power minus 1. Here no dimensions of mass, so we will write it m power 0. So this is the dimension formula for speed, or you can say the velocity. Speed and velocity has the same dimension. Now acceleration. Acceleration is what? Rate of change of velocity, that is called the acceleration. So velocity upon time. So velocity or speed has the same dimension formula we just calculated. M power 0, L power 1 T power minus 1, and time has a dimension formula power T. As time is only once, so its power 1. So now the dimension formula of acceleration m power 0, L power 1 T power minus 1, this and this also go upside, so minus 1 minus 1 minus 1 minus 1, that is m power 0 L power 1 T power minus 2. Now let us calculate the dimension formula for momentum. So momentum, that is the product of mass into velocity. So mass has the dimensions of m, as it is only once, so m power 1. Velocity has the dimensions of m power 0 L power 1 T power minus 1. M power 1, this power 1 plus this power 0, so 1 plus 0 1, L power 1 T power minus 1. So this is a dimension formula for momentum. Now take one more, that is with force. So force, it is the product of mass into acceleration. So mass has a dimension of m power 1, acceleration we just calculated, m power 0 L power 1 T power minus 2. So what will be there? M power 0 L power 1 T power minus 2. So now m power 1 into m power 0, so 1 plus 0, that is 1 L power 1 T power minus 2. Impulse is defined as force into time. Force acting for short time is called as the impulse. So dimension formula will be the dimension formula of force, that is m power 1 L power 1 T power minus 2. So you can directly put the formula here, or you can define it from here, mass into acceleration. Time, that is what T power 1. So therefore m power 1 L power 1 T power minus 2 plus 1. T power minus 2 into T power 1. This is simply when you have the same basis, like a power m into a power n. So what happens? Power plus. Bases are same, we are multiplying these, so power will be added up. So m power 1 L power 1 and T power minus 1, minus 2 plus 1, that is what? Equal to minus 1. So dimension formula of impulse will be m power 1 L power 1 T power minus 1. Now let us calculate the dimension formula for work. Work is what? The product of force into displacement, or you can say the force into distance. So now you can directly apply the dimension of force, that is what? M power 1 L power 1 T power minus 2. Displacement or distance. Displacement or distance has the dimensions of length, so L power 1. So m power 1 L power 1 into L power 1, so power will be added up, T power minus 2. So किया जाएगा तो देखो m power 1 L power 2 T power minus 2. Potential energy. Potential energy has the formula mgh. M for mass, g for acceleration due to gravity, and h for height. So mass has the dimensions of m power 1, acceleration z we have calculated, you can directly put here. So acceleration has the dimension formula m power 0, l power 1, t power minus 2. So just put here m power 0, l power 1, t power minus 2. Height that is length, so it has the dimension formula of l. So therefore m power 1 plus 0, that is 1, l power 1 plus 1, and t power minus 2. So you have m power 1, l power 2, t power minus 2. So in this way you can calculate the dimension formulas of physical quantities. So thank you for watching the videos. If you like the videos, you can like and share. Thank you very much.